We're going to take a look at the prefix, conversions, and scientific notation. You probably have already learned that meters to kilometers instead of converting feet to miles. That's where we use prefix. It's used to change the SI base units to by powers of 10. Now it helps you understand the big units and also differentiate between the small units. Big units are kilometers and small unit is without a prefix meters. Some of the prefixes that we'll be using in this class are micro, 10 to the power negative 6, milli, 10 to the power negative 3, centi, 10 to the power negative 2, and some other units that are bigger are kilo, 10 to the power 3, and mega, which is 10 to the power positive 6. Now, if you look at this chart, there are two big units, prefixes, and there are three small prefixes. Other prefixes that we'll be using, you might have heard about a nano, which is 10 to the power negative 9. You might have also heard about giga, which is 10 to the power positive 9. That's nano is used for nanotechnology and giga is usually used for gigabyte data. Now when we talk about conversion, it means converting to other units, and a fancy name of it is called dimensional analysis. It's the method of treating units as algebraic quantities which can be cancelled. So let's do a couple of examples. Let's start with a simple one, converting 1.34 kilograms to grams. So we'll write out the quantity that is given to us and then put a fraction. I want to convert the kilograms into grams, so I will want to cancel out the kilograms and my final answer will come out as grams. Finally, I plug in the conversion factor, which is always given to me, and that's my answer. For looking at second example, which is a little bit tricky because I have to convert the kilometers per hour into meters per second. So that involves two conversions. One is kilometers to meters, and I'll write down the conversion factor, and also from hours to seconds. So this will be also given to you as a conversion factor. Now using the same factoring method, I'll write down the number that is given to me that needs to be converted, write down the conversion factors in the form of a factor by making sure that kilometer gets cancelled into meters, hours gets cancelled into seconds. And then the rest is multiplying and dividing the numbers. So my final answer is meters per second. My third example is usually one of the favorite ones for physicists, to convert 1 year into seconds. So let's start off writing 1 year. Then I will think of what conversion do I know about a year. I know how many days it has. So let's start there. Then I know how many hours are in a day. And then also I know how many seconds are in an hour. So let's write down the conversion factors. And the rest is again plugging in the conversion factors to figure out how many seconds are in 1 year. And just multiplying the top numbers, I get my final answer in seconds. Okay, last we're going to look at scientific notation, which is used for extremely large or extremely small numbers. That's what physicists sometimes have to deal with. So in case of writing a number in scientific notation, we usually represent it as powers of 10. So let's do an example of a large number and see how we can write it in scientific notation. So instead, this long number can be written as, I will start by putting the decimal place after the first digit. So it will be 6.41. And then I'll count how many places did I move the decimal point. So I'm going to count it out 3, 4, 5, and 6. Since I'm moving towards the right, I will write this as a power of positive number. So it's 6 places to the right, positive 6. And that 6 is telling me that I had to move the decimal place. Now let's take a look at a small number. Again, 3.95. I will count how many places I had to move the decimal point. Notice that my arrows are going to the left. So I'm going to the left. I will have to put a power of negative number. So this is 3.95 times 10 to the power negative 4. And since it's towards the left, I will put a negative sign. Now, scientific notation is required to provide the answers only when asked. Also, you have to keep in mind to use the correct sig figs. We'll talk about